Yeah.
Hi and welcome. First, if you're not used to Zoom and the presentation is shown in a small picture, you can press the 3 dots in the corner of the picture and then select Pin. Then you will see the presentation in a bigger picture. So, my name is Emma and I'm here with my colleague Jakob.
Hello.
And today we're going to have a presentation mostly about our program Topocad and the module called Net Adjustment. But I'm going to start with a little background story about where we come from. So we work together at a company called Adtollo. We develop and sell software programs. We're based in Sweden and are 19 coworkers, about 50% are developers, and the remaining handle sell, market and administration. And the company has been around since 1993, and a lot have happened since. So, as I said, today we're going to look at one of our software programs called Topocad. So, Topocad have multiple functions. You can, for example, use it to calculate survey data for geographical information systems, BIM, and additionally we have full functionality for CAD. You can customize your license depending on your personal requirements. And soon Jakob will give us a live demonstration specified on our net adjustment module. Oh, and one last thing. If you are interested in a trial version after the presentation, you can just reach out to us and we'll set up a license.
For free.
For free. And well, the net adjustment module is based on something called HMK. It's a handbook in survey and mapping, published by the Swedish Survey Institute and made to standardize the work. And well, why is this good? If everyone do the same, the quality will improve. It helps in procurements, so it's easier to see the requirements, to set the requirements correct from the start, and the work will get more effective and the company will therefore save resources.
That's right.
Yes. So.
All right. So in this presentation, the reason why we're talking about HMK is because this is just recently had a big revision, which we already integrated into our software. And you can follow the methodology they describe really well in Topocad. So we think this can be valuable to share with the international community. So first off, we go into the preparation. And this is really important. Don't skip the preparation.
Can you please explain why it's so important to have a good groundwork?
Yes, certainly, Emma. The preparation is very important because in the beginning of the project, you have more time later on when the construction starts to pick up speed. It can be very costly if you have to redo some steps or you're not sure about your survey in the field. So you want to do a good preparation and do this ahead of time so you cause less stress and don't cost the whole project a lot of money. So it's very important. First off, we describe the purpose of the network, and of course, a different kind of project required different tolerances from the network. And then next, you formulate roles and time plan. So who is going to be doing what and when? And from that, you can specify the requirements. And After this, you can simulate a network in Topocad, which I will show you right now. And so next up is to simulate the network, and this is done very easily in Topocad. First, you can import the known points. We can enter new points here, and also add the observations with a couple of clicks. And this is something that you can then calculate to control that you meet the requirements you set for your project. And this project is actually in Linköping, in the middle of Sweden, which is something I've helped one of our users with. And at this stage, we can now make a control here, and we can check controllability and some other values here to see if they are they look acceptable. And we will repeat this process until we're happy with it. In this case, it looks quite good. The max value here for controllability is 1, and we're almost at 0.7, which is more than we need in this case. And then you head out to the actual site in real life, and there you can check if your draft of the network will work out for real, or you have to go back and adjust the design. And after this step, you can write out a plan of how you're going to do all of the survey, and then you head out to the field. So at this stage, we will usually do a reconciliation with the customer to get an okay with the design, and to probably talk about costs. And next up, we just double check your instrument before you go out to the field, and go ahead and do the actual surveying. And after this, we do the network adjustment, which is the main part. And this is, of course, something we will do in Topocad. The workflow of the network adjustment is something like this. This is a set of steps that we will go through, which is the typical series of steps you would do. But of course, sometimes you will add and go back. But this is the most standard kind of adjustment you would do. So first up, we have the reduction, and this is where you get the reduced mean values. And this is something that you start here in the survey document. You press reduce, and you can get a report which shows the spread of your observations. And this is a stage where you can detect bad observations early on. And this is something you will take with you into the next step. So this is looking good. Then we get the reduced file with just the mean values, and this also has added on the sets of angles that went into the mean value, which will be used for weighing the observations at the next stage. So the next stage is to set the weights, and this is done automatically in Topocad. And this is used with the help of the instrument's uncertainty value. And this is something you can just write in from your data sheet from the instrument manufacturer. And if you can notice here, we have adopted the latest standard in the guide of expression of uncertainty in measurements. So we go with the standard uncertainty here. And yeah, this will give you their weights just to help you get the precise calculation. Next up, we do a free adjustment. And this is a way to objectively analyze the observations. And this is where you let the node points be set free so you can recalculate these so you don't get the error of the known points to show on your observations, so you can objectively isolate them. And at this stage, we can make a calculation, and we are a bit over the threshold here. And at this point, we can check out the removal of gross errors, which we can easily do with the help of the three-step principle.
Could you tell us a bit more about how it works? I don't really know what that is.
Definitely. So the three-step principle is a way to see the spread of the sigma values. So this is now called the standardized residuals. And theoretically, we should aim to have all of the observations below 3. We should have 95% below 2 and 67% below 1. And the most important part is to remove the ones above 3 here, which is what we usually call the gross errors. All right, so here we can just press a button and remove this. And you get the first value here is the biggest error here. So we can do a few of these. This is below 3, so I'll keep that one. Now we are well within the threshold here, so we're happy about it. The observations looks good. So now we can go ahead to the next step, which is a fixed adjustment. So the fixed adjustment is a typical real-world adjustment where you have transformed your measurements into the coordinate system of choice. And so in Sweden, we have SWIREF 99, for example. And here you lock your known points. So if you have problems with the known points, it will increase the standard error of unit weight. And indeed, in our case, we got a really high number here. We're about 5 times above the limit. This means we have a problem with our known points. So that takes us to the next step, which is the test of known points, which is a really good way to easily solve this. We can just let the algorithm find the worst points and release them. And just like this, we get a result. It unlocked 2 of the known points. So we will recalculate this to get a better network with less tension. All right. And as we can see here, now it's looking great. So, of course, you can also get a report for this step. But now we can go ahead and get into this, the last step, which is the report phase, actually. So I can just quickly show you this report, which gives you a lot of parameters for the known points. And also we have, for all the tests, we have reports, and for the entirety of the network, we can get all of this with a couple of clicks. So this is something you want to save maybe into a PDF file or any kind of file you would want to share. You can select here very easily. And here you have your calculated points, known points, all the observations with all the parameters you might want to look at. And of course, you have the a summary at the bottom here also. So this gives you a lot of information on what you have been calculating and all a great overview of the observations also. And this is the final step. Here you will reconcile with your customer once more, show him or her the reports, and be happy with your final product, hopefully. And after this, you can plan a follow-up and eventual addition with your customers, and maybe document your experience for future needs. And this was actually the whole workflow and methodology from HMAK, which we have gone through with you in Topocad.
So thank you for your participation today, and thank you, Jakob, for a great demonstration. If you have any questions or want to know more about Topocad, you can contact me or Jakob on the contact info on the screen. You can also visit our website, and once again, we provide free trial license for 30 days if you want to try it out. Just let us know and we'll give you a license.
Thanks for watching. And don't hesitate to reach out to us as you have our contact info right here.